Hello juniors, today we're going to continue with electronic assignment number 12, which is about degrees, radians, arcs, and sectors. If you remember from last class, we have seen the basic definitions of what a trigonometric function is about. It's basically a function that has a repeating pattern, right? We have seen some real life applications of this, which we're going to we will be studying later on in future live sessions. We have seen how to convert degrees to radians and radians to degrees. And finally, we have seen the definitions of these terms. What an arc is, a sector is, a chord, and a segment, right? Remember, the arc is this part over here. You can see it clearly in the figure below. The arc is part of the length of a part of a circumference. The sector, we call it the slice of a pizza, right? And then we have the chord, which is a line that cuts the circle, not passing through its center. And finally, the segment, which is the area between a chord and an arc. Okay. And then we have seen these two formulas. The first one is to find the arc length. Remember, it's the radius times theta, where theta must be the angle measured in radians. Remember that rule. If you use the angle measured in degrees, you would get a wrong result. And same thing for the area of a sector. If we want to find the area of a sector, we have this formula, which is 1/2 times radius squared times theta, where theta must be in radians, okay? We have solved a basic example in order to apply these formulas, which, if you remember, are available here in the formula booklet. You see that in the formula booklet, we have the same acceleration here. It says theta is the angle measured in radians. And same thing here. Theta is the angle measured in radians. So that's something you need to remember when applying this formula. Okay, so for today, we're gonna see 3 more examples to see how these concepts apply. So the first one says, a circle has radius 2.5 millimeters. Find the size of the central angle subtended by an arc length of 9 millimeters. Okay, so if we identify our data first, we're gonna have that the radius of this circle is 2.5 millimeters. And that the arc length, remember the arc length is this, right? It's symbolized with an L. The arc length is equal to 9 millimeters. So with these two pieces of information, we want to find the size of the central angle. So we want to find theta, right? That's our variable here. So since we have arc length and we have radius, we can apply the formula, which is that the arc length, let me do that here, the arc length is equal to r times theta. So we replace the information here, and we're going to be finding theta, which will be in radians according to our formula, right? So this would be 9 equals 2.5 times theta. So then we solve for theta, and we get that theta is equal to 3.6. Remember, this should be in radians. So it's 3.6 radians. So this would be the result. If the exercise asks for theta in degrees, then we will have to convert this to degrees, which is something that you should already know how to do. Okay, but if it doesn't ask, we can leave the answer in radians and that will be fine. Okay, so that's it for that example. Now let's move on to the next one. It says, in this circle, arc AB, that's this, is equal to 7.86 centimeters, and the area of the sector, that means all of this, is equal to 23.58 centimeters squared. Find the central angle theta and the radius r. So we want to find the radius and the value of the angle. So let's write down our information. One thing is that the arc length is 7.86 centimeters, and the other is that the area of the sector is equal to 23.58 centimeters squared. So maybe we can use both formulas, the one to find arc length and the one to find area of a sector, in order to find our required information, which are both the angle and the radius. Okay, so for the first formula, we know that L, arc length, is r times theta, right? So we're going to write 7.86 is equal to the radius, which we don't know, and theta, which we also do not know. So I'm going to leave it like that for now, and I'm going to write the formula for area. Remember, it's 1/2 times radius squared times theta, just as you can see in the formula booklet, right? 1/2 radius squared times theta. So we're going to fill in the information. We know that the area is 23.58, and this is equal to 1/2 times radius squared times theta. So I see that I have two equations with two variables, right? R and theta. That means that I can solve this. Whenever I have the same amount of variables and equations, I can solve this. I see that, for example, this 2, I can take it to the other side multiplying here to make this expression look better. So this would be 47.16. This is equal to r squared times theta. So one thing I see is that, for example, in this equation over here, let me do this with a different color. I can solve for one of the variables. Leave one of the variables alone, for example, theta, and plug in the equivalent value in the other expression, right? So I can say that from this equation, for example, let me do it here, 7.86 divided by r is equal to theta, right? If I take the r dividing to the other side. So this equivalent expression, this one over here, I can take it and replace it right here, right? Instead of the angle theta, I'm going to write its equivalent value. So we would have that this is 47.16 equals r squared, and instead of theta, we're going to write 7.86 divided by r. So you see that we only have one variable here, which is r, so we can solve this. I can simplify this r with one r over here. So we're going to have that r is equal to 47.16 divided by 7.86. You can do this in the calculator and should get an answer of 6 centimeters. We get a pretty result. So the value of the radius is 6 centimeters. So now we need to find the value of theta. We already have this equation where we have left theta alone, so we can replace the value of r into that equation, and we would get that theta, let me do it here, theta is equal to 7.86 divided by 6. So the value of theta, remember this will be in radians, is equal to 1.31 radians. So there you have, we have found the value of r and the value of theta. Okay, now let's see, well, we have two examples yet, this one and one last one, which is a challenge exercise. Let's see this one. It says, the diagram shows a circle with center O and radius 5 centimeters. Find the area of the shaded region to 3 significant figures. So basically we want to find the area of this this was called a segment, right? We have a chord here and we have an arc. So the area which is in between is what we call the area of a segment. Okay, so how do we find the area of that shaded region? We have the radius, we have the angle. Remember to always try to plan what you're gonna do. For example, what I see here, and what we will need to do to find the area of the segment, is we could first find the area of the whole thing, right? The area of the sector, right? And then we could find the area of only this triangle over here, right? We already know how to find the area of a triangle with the previous formulas we have learned. So once I have the area of the sector, which is a complete thing, and I have the area of the triangle, which is just this, if I subtract both areas, I will be getting the area of the segment. Okay, so that's exactly what I need to do. So let me write that down. We can say that the area of the segment is equal to the area of the sector minus the area of the triangle. Let me write this as OCD. Triangle OCD. So that's what I need to do. So let's concentrate on finding the area of the sector first. To find the area of the sector, we know the formula is 1/2 times radius squared times theta. We have all of that information. Our angle is already in radians, so we can use that same value. So we're going to get that the area of the sector is equal to 1/2 times the radius, which is 5 squared, times theta, which is 1.46. So we solve this. We solve this using the calculator, and we would get a value of, let me see, 1/2 times 5 squared times 1.46. 18 0.25, we're talking about centimeters squared. So there we have the first part of what we need to find. Now we need to find the area of OCD triangle, right? So let me do that. I'm going to do it down here. The area of OCD triangle. If you remember from the formula of area that we have in the formula booklet, this one over here, area of a triangle, 1/2 AB sine of C. We have all of that information for that, right? We have the two sides and the included angle. So we can apply the formula and say that area of OCD would be equal to 1/2 times, this would be times 5 times 5 times sine of the included angle, which is 1.46. Remember that in order to solve this, and this is very important, in order to be able to solve this, our calculator, let me show you. Let me see if I can show you this. Calculator must be set to radians. If it's not set to radians, then you will get a wrong result. So make sure that you check that your calculator is correctly set to radians first. Remember, it's shift menu, and then you go to angle and you click on radians. So once you have done that, then you're gonna find the area of the triangle. OCD triangle is equal to 1/2 times 5 times 5 times sine of 1.46. You should get an answer of 12.42 centimeters squared. And you see that logically, this area over here is much smaller than the area of the sector, which should be that way because the area of the triangle is smaller than the area of the whole thing, the area of the sector. So make sure that you get a logical answer. If you're not getting a logical answer, maybe you haven't set your calculators correctly. It should say radians instead of degrees. Okay, so finally, once we have area of the triangle and area of the sector, we can now find the area of the segment by subtracting both values. So the area of the segment would be equal to 18.25 minus 12.42. And we would get the area of the segment, which will be equal to, let me see, 18.25 minus this answer, and I get a value of 5.83 centimeters squared. So this is the area that we are looking for, the area of the shaded region, which is this yellow part over here. Okay, this is, let me just clarify, this is a segment. Okay, so with these examples, we have covered all of the basics that you need to know for this particular assignment. And now we're going to try to do a challenge exercise, which involves knowing all of these different concepts we just covered. So it says, circle O has radius 4 centimeters. So let me write the information here. This is 4 centimeters. Circle P has a radius of 6 centimeters. So this would be 6 centimeters over here. The centers of the circles are 8 centimeters apart. That means that this distance over here, which is the distance from center to center, that is equal to 8 centimeters. Am I right? 8 centimeters. Okay, if the circles intersect at A and B, this point and this point, find the blue shaded area in the diagram. So we want to find, our objective is to find this area over here. So let's first plan how we're gonna do this. Something that I see that may be interesting to solve this problem is, for example, take a look at what will happen if we separate this figure by using the intersection points A and B. I see that we have a segment over here and another segment over here. And from the previous example, you should already know how to find the area of a segment, right? Let me color this just for you to distinguish. This would be one segment over here, which I'm gonna call, let's use the same color. This would be, I'm gonna find the area. Let me see if I can use a better arrow there. This would be area of segment number 2. Area of segment number 2, I'm going to call this, and I'm going to call the blue one, and call this, let me see if I can do the same arrow. Nope. That's better. I'm going to call this area of segment number 1. Okay, so we already know how to find each of these areas of a segment, right? We just need to find the area of the whole triangle. For example, for this blue one over here, we would find the area of the sector, which is the whole thing, and we're going to subtract that by the area of this triangle AOB, right? And for the purple segment, we're going to first find the area of the whole sector here, the whole slice of the pizza, and we're going to subtract that by the area of this triangle over here, which is PAB triangle. Okay, so we already have the plan of how to solve this problem. Now let's write all of this information down. Okay, so let's see, what else do I have here? No, that's all of the information I have. Okay, so let's write our plan. We're gonna say that the area of, remember that the shaded region is the whole thing right here, right? I separated into two colors here just to distinguish what we're gonna do, but remember our objective is to find the area of all this region here. So area of shaded region, is equal to the area of segment number 1, which is this one over here, plus the area of segment number 2, which is the purple one over here, right? So that's what we need to do. Okay, so I will need to focus on finding the areas of each of these segments, and to do that, I already know what I need to do, right? I need to apply area of a sector minus the area of the triangle. But I see that we still have one small trouble. And that trouble is that I do not have these values of the angles. I do not have beta and I do not have alpha. So I will need to find those angles first. So let me write that here. Finding angles beta and alpha. To find these two angles, I see that, for example, we have this triangle over here, OAP, right? For OAP, we have 3 sides. We have this side, and this side. So I can apply, for example, cosine rule in order to find this angle over here, which I can call, let me call this, let's say, theta, right? So once I have theta, I can multiply that by 2, and I will have the complete angle, which would be angle beta, okay? So then I will have angle beta, and I can do the same thing. I can find this angle here, which I can call, for example, mu, and then multiply that angle by 2 in order to get the complete angle, which would be alpha. And then I would have all of the angles I need to solve the problem. Okay, so first let's focus on beta. Sorry, on finding this angle theta, right? So we're gonna apply cosine rule, and we're gonna say that cosine of theta, which is half of beta, is equal to the opposite side, no, sorry, the adjacent sides squared, so 4 squared, remember the cosine rule, 4 squared plus 8 squared, minus the opposite side, 6 squared, divided by 2 times 4 times 8. This is what the cosine rule for the angle tells us. Remember that this formula is also available in the formula booklet right here. Okay, so if we apply the formula and we solve, we're going to get that theta is equal to, if your calculator is in, let me see, if the calculator is in radians, then you should get the angle in radians already. So this is 4 squared plus 8 squared minus 6 squared divided by 2 times 4 times 8. I strongly recommend working with radians already, right? Because you're gonna have to apply the formula later on using radians. So this is the angles you get in radians, 0.813. That means that beta which is the complete angle we're looking for, is double or 2 times theta. So if we multiply this by 2, we're going to get the angle, which is 1.63. We can round it to 3 significant figures. 63 radians. Okay, so we already have angle beta. Now, we're going to do the same thing. I just forgot to write here what triangle. I'm going to write it like this. This is for triangle. This was OAP. Triangle OAP. So I'm going to do the same thing now to find this angle, mu. I'm going to apply cosine rule to the same triangle. So I'm going to do that here. I'm going to copy this to buy some time. There you go. Triangle OAP. So now we're going to say that cosine of, I call it mu, is equal to 6 squared plus 8 squared minus 4 squared divided by 2 times 6 times 8. So if we solve this, we're going to get mu, which is half of alpha, which is the angle we're looking for. So we're going to get that this is, let me see, shift cosine of 6 squared plus 8 squared minus 4 squared divided by 2 times 6 times 8. And I get a value of 0.505. 505 radians, which means that the complete angle, which is alpha, is double mu, 2 times mu. So this is times 2. Sorry, and I get 0. I will get 0.505 times 2, that's 1.01 radians. So there we have. We have the measures of angles beta and alpha. Once we have both, now we can solve the problem just as we were planning at the beginning, right? We can find the area of segment number 1 and then find the area of segment number 2 and then add those two values. So let's work with area of segment number 1 first. Area of segment number 1. So to find the area of segment number 1, we would have to find the area of the sector. Let me write this, area segment 1. This is kind of a long problem, but it's not that difficult if you organize the problem correctly. So this is area of sector 1 plus area of this triangle, which is APB triangle. Yes, APB triangle. Area of APB triangle. So, to find the area of sector 1, we're going to say that this is 1/2 times the radius. In this case, for this triangle, the radius is 6. 6 squared times its angle, which is alpha, right? So times 1.01. So we get that the area of sector 1 is equal to area of sector 1 is equal to 18.18 centimeters squared. Okay, now I'm missing the area of triangle APB. So area of triangle APB is equal to find this, the area of this triangle, it's, remember the formula, 1/2 times the adjacent sides, which are both 6 and 6, right? Because we're talking about radius. So times 6 times 6 times sine of alpha, which is 1.01. Remember, your calculators must be in radians, okay? So the area of triangle APB is equal to, if you solve this, you're going to get 15.243 centimeters squared. That means that the area of segment 1, I'm going to write this, area of segment 1 is equal to the area of the sector minus the area of the triangle. So this is 18.18 minus 15.243, and we get an area of the segment, 1, which is equal to 2.94 centimeters squared. Okay, so there we have. We already have this blue region over here. Now we're missing this purple region over here. To do that, we need to work with area of segment number 2. Area of segment number 2. So we're going to follow the same process. We're just changing the information. We're going to say that, let me copy this. We're going to say that area of segment number 2, sector 2, and the triangle changes. So this would be area of segment number 2 is equal to area of sector number 2 plus the area of this triangle, which is OAB triangle. OAB triangle. OAB. So we're going to find the information. Area of sector number 2, area of sector 2 is equal to 1/2 times radius squared. The radius in this case is 4 instead of 6. So times 4 squared times beta, our angle, which is 1.63. Remember, you should write this angle in radians. So we solve this and we get the area of sector 2, which is equal to area of sector 2, 13.04 centimeters squared. So that's the area of sector 1. Now I need to find the area of triangle OAB. The area of triangle OAB is 1/2 times the sides, which are 4 and 4. Both are radius of the circle. So this would be times 4 times 4 times sine of the angle, which is beta. Beta is 1.63. Okay, so we find the area of triangle OAB, and we get a value of 7.99 centimeters squared. So once we have the area of sector 2 and the area of triangle OAB, we can find the area of segment 2, which would be equal to the subtraction, 13.04 minus 7.99, and we would get the area of the segment, which would be equal to 5.05 centimeters squared. Okay, finally, we have the area of segment 2, the area of segment 1. So we said at the beginning that the area of the shaded region is the addition of both areas of segments. So finally, we would say that the area of shaded region is equal to area of segment 1, 2.94, plus area of segment 2, 5.05. So finally, this is the answer. We get that this is 7.99 centimeters squared. And this would be the answer for the area of the shaded region we were looking for. Okay, so you see that this was kind of a long exercise, but actually not that difficult if you really understand what you need to find, right? So I think that's it. Yes, so that's it for this electronic assignment. I hope this was clear. If not, please let me know and we're going to clear doubts in future live sessions. Thank you for your attention and see you.